Yes,
Repeating the failure?
Yes, yes, yes. It's probability of the risk.
Okay. Repeating the failure.
Excuse me, the effect of the risk. Consequence of failure, CF, is it's meaning the effect of the risk.
Defect?
Effect, impact.
Effect, بله effect. تمام دكتور تمام thanks.
Okay, or impact of the risk. Okay.
بله impact or effect. بله.
Yeah. Any question, engineers? Okay. Continue. Mr. Engineer Abisale, any question? Okay. So when we want to make a chart for qualitative risk analysis, the horizontal axis is the effect or impact of the risk, and the vertical axis is belong to probability of the risk. And by multiplying probability by effect of any risk, we can calculate the risk number. Okay.
Doctor, please, okay. Doctor, do we get this probability when conduct a survey on site, a survey paper?
Excuse me, please repeat your question.
I mean, how we get this probability of failure inside by paper or by what?
Okay, we discussed that for determining the probability and effect of any risk, we must make a standard in our projects, in our team. Our team is a risk management team. Okay, we must make a standard for effects and probability of risks in our projects. Okay, for example, in this example, they determined the numbers from 1 to 10 for effects and 1 to 10 numbers for probability. It's a standard, internal standard, no problem. Because according by this number, equal about all of the risk. Our standard must be equal, must be the same for all risk in our project, okay? And we use this risk number for ranking of risk in the stage number 3, that is qualitative risk analysis. Okay, it's an internal or inner standard in our project, and we must make a standard when in the first step. First step is planning risk management, or first step is risk management, to make a risk management plan. Okay, we discussed in last sessions. And in our plan about risk management, it's a document in our project, in our risk management plan. In risk management plan, we must determine the standard and equal a standard for all our risk in our project for probability and effect of risk in or risk management. Okay, it's a internal standard in our project. Okay, Mr. Engineer Baha asked that this project is good or not. You can watch the chart, for example. You see that most of the risk are in medium region. Almost the risk in this project is the medium risk. So this project have a medium risk almost, and some of them are have a low risk, and high risk in the project is very little. A few risks are in high risk region. So almost this example or this project in this example have a medium risk, and it's good. This diagram show in general, but we must manage the risk in details until the latest step, that is monitoring and control the responses of the risk. Okay, but this example is with almost medium risk. Okay, engineers, any question? Yes, Mr. Engineer Batul Nama Atiya asked that we can change the method of this example. Yes, because we have internal or inner standard for probability and effect of the risk, and we must make the standard from the first step, that is planning risk management. Yes. Mr. Engineer Batul Namatiya. Other question? And this method is not, Mr. Engineer Batul Namatiya, this method is not constant. It's not stable. And we can change the method. But the overall steps in 6 steps are used in any project. But in detail, there are some difference between the project, between the standards that we use in any project. It's according to the condition of our project and condition of team about risk management. Okay. Engineers, any question? Any other question? Okay. Excuse me, only for 1 minute, I disconnect my microphone. Only for 1 minute. Okay. Thank you, engineers. Excuse me. Mr. Engineer Abbas Al-Baizai, you hear me?
Bala, doctor, I hear.
Okay, thank you. Okay, engineers, about the question that Mr. Engineer Batul Namayatiyab asked me, the last one. Please back to the first step of risk management, that is planning risk management, or to make risk management plan. In the items and details of risk management plan, we discussed that we must make a standard for effects and probabilities of the risk at the first step, that is planning risk management. And the risk management plan is a document. It's one of the documents in risk management that will be reported to project managers, discussed. Okay, so we must make a standard for effects and probabilities of risk in our project. It's an internal standards, not in general and national or international standard. But about the risk number, about the risk matrix, and about the risk chart, the number of risk will be determined by multiplying probability of the risk by effect of the risk. And about the risk matrix, the risk matrix will be determined by multiplying probabilities and effect of the risk. And about the chart of the risk, like this example in slide number 8, the horizontal axis is effect of risk, and in our standard, in our project, and the vertical axis is about probability of the risk. We can change the position of these two axes, no problem. But one of them must be effect of the risk, and another one must be belong to probability of the risk, okay, by our standard. The main method and the main steps for risk management in any project are similar, and are according to the standards. While in details, there are many differences between risk management in different projects in details. Okay. And about the next technique, that is top 10 risk. Excuse me. In this slide number 4, we discuss that risk quantification tools and techniques are include probability impact matrix. Next one, the top 10 risk item tracking, and the last one is expert judgment. We are discussing about these tools and techniques for risk quantification tools. So we discuss about the first tool and technique, that is probability impact matrix or chart. First one, by these examples. And the second one of tools and techniques for quantitative risk analysis is top 10 risk item tracking. So top 10 risk item tracking is a qualitative risk analysis tool. So that helps to identify risks and maintain or make an awareness of risks throughout the life of a project. Establish a periodic review of the top 10 project risk items, because we discussed that the risk management, like project management, is a cyclic and dynamic variable procedure. So list the current ranking, previous ranking, number of items. The risk appears on the list over a period of time, and the summary of progress made in resolving the risk item. It's about top 10 risk item tracking tool. And this is an example for this technique, example of top 10 risk item tracking. For example, from the left, the rows are belong to risk items such as inadequate planning. After that, poor definition of scope. These are the root or causes of risks in our project. Inadequate planning. After that, poor definition of scope. Next one is absence of leadership or not good leadership, or not good choosing the leadership. Absence of leadership. After that, poor cost estimates in our project, and the last one is poor time estimates. And about monthly ranking means monitoring and control. Monthly ranking of risks by qualitative risk analysis, ranking by qualitative risk analysis, because top 10 risk is the tool for qualitative risk analysis in the first step of risk management. So monthly ranking, for example, this month, last month, and the next one is about number of months. About inadequate planning, this month the ranking is 1, after that last one 2, and number of ones is 4. And for example, poor time estimates, this month the number is 5, last month 5, and number of points 3. And the last column from the left is risk resolution progress. For inadequate planning or not sufficient planning, the risk resolution progress is working on revising the entire project plan. And for poor definition of a scope, holding meetings, some suitable meetings with project, customer, and sponsor to clarify the scope. And about absence of leadership, for example, risk resolution progress, or the solution, the problem in this part is just assigned a new project manager or lead the project after old one quit. And for poor cost estimates, the resolving or resolution is revising cost estimates. And about full-time estimates is so revising schedule estimates. Okay. Any question, engineers?
Please, Doctor,
Okay.
get these numbers also from standard or from
Yes, yes.
probability with effects?
Yes, yes. Yes, according our standard in our project, these numbers. For ranking,
And
ranking. Okay.
Very, Doctor. Thanks.
Okay. Any other question, engineers? And the third tool for qualitative risk analysis is expert judgment or engineering judgment. Expert judgment. It's better. So many organizations rely on the intuitive feelings and past experience of experts. We must rely, but the selection of that experts are very important. So many organizations rely on the intuitive feelings and past experience of some experts to help identifying a potential project risk. And experts can categorize the first step risk as high, medium, or low without more sophisticated techniques. And can also help create and monitor a watch list or a scan or rapid watching. A watch list, a list of risks that are low priority but are still identified as potential risks. And about the detail of next step of risk management, that is quantitative risk analysis. The last one was about qualitative risk analysis by risk number that determine with multiplying risk probability by risk effect. And the next step is quantitative risk analysis. So often quantitative risk analysis follows after qualitative risk analysis, but both of them can be done together. Sometimes in a small to medium projects, about the size of the project, about the complexity of the project. Sometimes we can deal with quantitative and qualitative risk analysis with together sometimes. So often this step, quantitative risk analysis, follows qualitative risk analysis, but sometimes both can be done together in a small to medium projects about their size and their complexity. And in large and complex projects involving leading edge technologies, involving updated technologies. Leading edge technologies often require extensive, expensive, quantitative risk analysis about large and complex projects. And the main techniques that we can use in this step, that is quantitative risk analysis, are included. First one, decision tree analysis, the first tool in quantitative risk analysis. Next one is simulation. And the last tool is sensitivity analysis. So main techniques in the step of quantitative risk analysis include decision tree analysis. Next tool is simulation, and the last tool is sensitivity analysis. Okay, any question, engineers? You can connect your microphone and ask your question, or write your question in the chat part or chat box. Any question, engineers?
Excuse me, Doctor.
Okay, Mr. Ali.
Just for the first one, decision tree analysis.
Yes, we will discuss. We'll discuss by examples. Only these are the title of the tools.
Okay.
Okay. After our explanation and examples, if you have any question, you can ask me. Okay. These are only the title of these tools we will discuss.
Okay.
Any question, engineers? Ladies and gentlemen. Okay, Mr. Mohammed Salman.
Assalamu alaikum, Doctor.
Assalamu alaikum wa rahmatullah, Mr. Engineer.
Doctor, sorry, I am present, but problem in mic.
Okay. It's a question or it's an answer or it's a news? What?
No, Doctor, no question.
Thank you. It's a
Thank
news,
you,
I think, yeah?
What?
It's a news, it's a awareness about your presence, yeah? It's not a question about the lesson.
Doctor, I'm present.
Yes, I know. No problem. I'm joking. Sorry. Okay. Mr. Mohammed Salman, we will discuss about the decision tree. That is a technique or tool for quantitative risk analysis in any project. Any other question, engineers? Mr. Mustafa, yes, we will develop, we will proceed, we will progress. Okay. Step by step. Okay. About decision trees, technique and expected monetary value, or EMV. Monetary, you know that is dependent on the money. Anything in the world is dependent on the money. So expected monetary value EMV, decision trees and expected monetary value. So a decision tree is a diagramming analysis technique used to help select the best course or best case of action in situations or cases in which future outcomes are uncertain. So we can use decision tree in quantitative risk analysis. I repeat, a decision tree technique is a diagramming analysis technique used to help select the best course of action in situations in which or that future outcomes are uncertain or outcomes are not certain. And the estimated monetary value, this parameter, this item, estimated monetary value, the expected value about the money. That means estimated monetary value, or EMV in abbreviation. EMV is the product of a risk event probability and the risk event's monetary value. Okay? Like the probability effect matrix, like that, but some differences. Estimated monetary value EMV is the product of a risk event probability, like risk matrix, and the risk event's monetary value, not effect, the risk. Probability and monetary value of the risk. And you can draw a decision tree to help find the EMV for any part of your project or all of your project. You can draw a decision tree to help find the EMV, estimated monetary value. This is an example for expected monetary value EMV. From the left, decision can be the project alternative 1, project number 1, or project number 2. And we can have more than 2 decisions or 2 projects or more than 2 alternatives. Okay? So about the decision, we can decide about the project or alternative number 1 or project 2. About project number 1, there are 2 ways. About probability, P factor, multiply or times outcome. Outcome is EMV, expected monetary value about that position, about that case. And about project 1, there is other case that the probability is 0.8 or 80%, and the outcome for this case is $40,000, but loss minus, but loss 40,000 minutes. But about the first case, the outcome EMV is positive. It's $300,000. So by multiplying 20% for first case in project 1 by $300,000, the EMV in overall will be $60,000, positive $60,000. And for case number 2, by multiplying 80% or 0.8 by minus or loss, $40,000, the EMV will be minus $32,000. And by position number 2, that its probability is 80%, we will lose about $32,000. And about decision number 2, project number 2, we are 3 cases. First case is by P equal to 20% or 0.2, and the outcome will be negative, minus $50,000. And by multiplying 50% to minus, 20% by minus $50,000, the EMV will be $10,000, minus $10,000. So approximately in case 1 for project 2, we will lose about $10,000. And for case number 2, with probability of 10% and outcome $20,000 loss, $20,000 loss, or minus $20,000, by multiplying 10% to $20,000 minus $20,000, the EMV for this case will be minus $2,000. So by choosing this case about project 2, we will lose $2,000. And about the case number 3 about project 2, by probability of 70%, and the EMV of positive $60,000, and by multiplying 70% by $60,000, positive $60,000, the EMV will be $42,000, positive $42,000. It's a benefit. So in general or overall projects, number 1's EMV will be 60 positive, $60,000 minus 32,000, that is equal to $28,000. And about decision number 2 or project number 2's EMV, expected monetary value, will be minus $10,000 minus $2,000 plus $42,000. That is equal to $30,000. So in overall, in this about the decision in the project, the EMV of decision number 1 or project 1 is lower than the decision or project number 2. So in general, by using this technique, decision tree. The project or decision number 2 is better than decision number 1 or project number 1. Okay. Engineers, any question? Yes, Mr. Haidar, we can use these ways by some difference in details for other projects. Yes, it's a very good question, Ms. Engineer Batul Nama Etiya. In this case, in this example, expected monetary value EMV is the base of our decision. Okay, by it's the base in other project can be changed. For example, the time of the project, for example, or the efficiency or effectiveness of the project, or the activity of the project. Yes. So the outcome in any project by using this technique can be changed. In this example, the expected monetary value EMV or in general costs is the base of our decision. Mr. Engineer Batul Namatia, other question? Any other question, engineers? And Mr. Engineer Batul Namatia. It is a very good question. Thank you, Mr. Engineer Batul Namatia. Okay, engineers, any question until now? Mr. Engineer Batul Namatia, did you understand? About your question? Yes? Thank you. Ladies and gentlemen, any question? Okay. So I think enough for this session. Any question, engineers? So we received the slide number 4. Number 14. Okay. Any question? Thank you, engineers. So until slide number 14, and we will continue in next week and next section. Thank you very much, and goodbye. If you have any question, I'm in the class. If not, you can go for your work, for your anything that you like. Thank you very much, and goodbye, engineers. Thank you.
Thanks a lot, Doctor. Thanks a lot.
Thank you, Ms. Engineer, and others.